All right, can we see the Spark AR opened here? Yeah, can we?
Yes, we can.
Okay. What we can do is that whenever I ask you something or you want to say something, I think there's a reaction button here. Like there's a reaction button, right? Can you see a reaction button at the bottom? The reaction button, the reaction, like it's emoticon. Then if
Yeah.
you, yeah, so if you click on the reaction, there would be some sort of reaction. And then, so if you like something, you can like kind of use that. If you say like, it's okay, you understood, the voice is okay, you can use these interaction to kind of, like talk through while teaching you, or you could say this thumbs up for if you understood something. If I ask you something, is there a thumbs up there? Is there a thumbs up? Like, I'm not sure. Yeah, there's a thumbs up, there's a heart. So like, oh, there's a lot of smileys. Okay, cool. So I'm gonna start with the heart. Yeah, that's how it works. Okay, so I can know like who understood, and if you have a question, then probably some smiley with the, I don't know, like a question smiley. Yeah, works. Okay. In the last session, we talked about what lies in the tool in the Spark Air. So this is a basic project. Like when you open the tool and open a blank project, this is what opens. Okay, there's nothing here. There's everything. Nothing in the patch editor, nothing in the scene, nothing in the assets. We haven't really talked about the patch editor yet. So this is what initially opens, like, and there are some elements that we can add from here. There's like face tracker, plane tracker, target tracker. As the name suggests, face tracker is enables you to track the face. So whatever elements you put in the tracker, they would be following the face's coordinates, rotation, position, right? Um, I'm going to talk about quickly with the hand tracker. Hand tracker is not supported on Instagram yet. It may be soon. Um, so it is only supported on Facebook. So if I try to add something, so hand tracker is basically, if right now my hand is not in the camera, but if I bring it here, you see that there are some select coordinate system comes up, like those arrows showing you the y direction, x direction, like that. So if I put anything here in the hand tracker, let's say if I put a plane here and the plane goes inside, so whenever my hand appears, there's going to be a plane here, correct? So I could kind of give any texture to this plane, maybe some sort of animation sequence of a fire, and it's like, yeah, maybe can become a Spider-Man. But yeah, we can make simple to complex filters using this. So just to explain, that's how face tracker works as well. So if you were not there in the earlier class, you can now kind of compare things. Like if you do same thing with the face tracker, and then you kind of add something here, let's say a plane, so it is going to um, you know follow your face. And similarly for every kind of other tracker, like a plane tracker, like a target tracker as well. So plane tracker is, it tracks a plane. So usually these effects for the back camera, and so as well the target tracker. I want to talk about importantly today about the data types in Spark AR, because whatever tools, whatever programs we write, it's kind of a visual programming setup. Spark AR is like a visual programming setup. So let's say you want to do some addition, or you want to do some subtraction, like wherever my hand was tracking this plane, or this, wherever my face was tracking this plane, I wanted to like kind of do some operations when, like maybe not here, just like go away, like maybe come ahead, or go in the back direction, and also apply some maths to it. So there's a way to do it. It's called patch editor. So if you open the patch editor, so it's like at the corner, You will see like show or hide patch editor, show or hide console, which is console is like a feedback from a JavaScript if you want to write that. Show hide asset summary. These are the assets. If I do that, oh, so asset summary is like whatever assets you have in the folder. Like if I add some assets here, let's add some Halloween background. So like you see that there's a texture added and what is the size of it, and then you can close it. Important is that like the patch editor, that's what we're going to talk about. Uh, we can kind of drag the entire face tracker here. That's how it works. Like I just gonna make you familiar with the patch editor. You can drag things here. You can drag things from here as well, and then apply them to something else. So everything has an attribute. Like this face has faces, it has some counts, like how many faces are there at the screen. So let's say if there's only one face, if there are like two faces, so I could kind of make some operation based on that. Like let's say if there are two faces on the screen, then do something else. If there's only one face, then do something else. So that's what the programming is. And the visual programming, it just makes it easier for us to like, hey, connect this to here. So connect this input to this output, connect this to this patch. So basically the patch is the program that we write into code, and that's been executed when you kind of connect the input to the output. So this thing is kind of selecting faces and passing it to this tracker. Did anybody have any questions? I kind of didn't see here. Okay. So yeah, so I'm going to take an example of a very simple operation. You can delete, like you delete whatever you drag it down here. You can also delete them, import them. You understand the patch editor, okay, or like how this works? Divya, you have already worked with the patch editor, right? Okay, let's
Yes,
add a
yes.
rectangle. Sorry.
Hello.
Yeah. Divya, all right, I'm going to add a rectangle, and this rectangle is full width and full height. I'm going to apply a material to it. Please ask me if you have any doubts, because I can't really go through the entire lecture that we did last time, because that's not ideal. And so do ask whenever you think that we did not understand this, so I can kind of like point some light on that. All right, so I added a rectangle, which is nothing, just an empty rectangle. I added a material to it, which is a standard material and does not have any other properties. I put it on flat, and as soon as I put it on flat, it doesn't matter what kind of lighting is there, so it becomes entirely white. It does not have any texture at the moment, so I click on this arrow here, which is nothing but kind of kind of a way to drag this texture to the patch editor. So right now I have this input here. So whenever you see something written here and there's an arrow in front of it, then you can kind of drag it down to the patch editor. And how to do that is that click on that arrow and it will be in the patch editor. Now I can apply some texture to it. As you can see, this is kind of a texture, and textures can be applied to this, and then you can say that, hey, apply this texture to this guy, and then we have the entire uh, texture applied to this rectangle. So I wanted to talk about today is the screen resolution, because every phone has a different screen. And I think Divya also faced this problem in his last filters, that there were there were different sizes in different phones. And let
Definitely.
me get this out of the way so that, yeah. So like how to resolve that is like every screen is like every phone is a different screen. Some phones are like of like iPhone 8, I know iPhone 10, OnePlus, Redmi. They all have different sizes, and everybody has different phones. So how do we make a filter which is kind of consistent on all of the screens and all of the phones? To do that, everything in the scene object is under device, like whatever device that we are launching our filter on, and then the device has a camera, and then we have our objects into it. So we bring out the device, and this device has some attributes. Okay. These are screen sizes, screen scale. So we will be going to work with the size and scale, because if you can see, this is right now an iPhone 8. An iPhone 8's screen size is that 750 pixels into X direction and 1334 into Y direction. So it's like a length and width of the phone. And a screen scale kind of represents like how 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 complex they are, how stretched they are. Like um, consider this example. It's a very interesting concept if you understand this one. So right now, this screen size is 750. This is like 750 from here to here. Okay. And 1334 from here to here. So on the screen, every pixel represents something. Like this is made of so many pixels, like 1 pixel, 2 pixel, 3 pixel, 4 pixel, like that. And then, so how, like a better representation of a pixel would be like, if I turn it on, remove this material. So like for an example, just consider this as an 1 pixel. It's not 1 pixel, it's more than that, but this is just a representation. So consider this is like a 1 pixel, the 2 pixel, three, four, five, six, seven. So that's how the screen is made of, like 1 pixel, 2 pixel, 3 pixel. And every screen has a different pixel to screen ratio. And that's what makes a resolution higher or lower. That's what makes a phone better or worse. So this screen size is also with a screen scale. So it also represents that 1 pixel is containing how many values of the screen. So if I divide this by the screen scale, then this is going to be like 1 pixel with one value. So that now this 1 pixel would contain just one value, not two data. Earlier, this iPhone 8 was compressed like 2 pixel at one place. So it was like the density ratio was 2. Here, it now we have kind of converted this to 375 um, and 667, I guess. Okay, so I am just going to put it aside for a moment, and I want to talk about data types in Spark AR. How many of you have some programming knowledge? Could you, yeah, just give me an heads up? Yeah, please be quick. Cool. Okay. So we know that there are some sort of data types that we kind of transfer our data from one input to output. So whatever program we make is kind of a system. Program is a system where there's something coming in, being processed, and just going out. So we have to define what our function can accept. Let's say if I have a function of I have a I have a motor, like a water pump in my house. So I know that function is that it sucks up the water and pushes up to my tank upstairs. So its input is water, electricity, and the output is just water. There's no electricity output, right? So I have two kind of outputs to this function of that motor is doing to me. So that's if you don't even have the programming languages, you don't need for a Spark AR, but understand this concept that like what a function does. A function does something based on some inputs and gives you an output. So there are some kind of inputs and outputs in Spark AR. So which is like data types. We call them data types, like what is coming and what is going out. So based on these things, there are certain types of data types. I'm just going to like add a value, just a value, like nothing is by default a number values like a zero number. But there are these kind of data types. Okay, there's a boolean, there's a color, number, pulse, text, vector 2, 3, and 4. Let's talk about them like very quickly. You will understand. So a boolean is a boolean. I think you everybody knows what is a boolean. It's boolean is like a turn off or turn on. Like something can be turn on or turn off. A light can be either it can be on, it can be off. Um, Answer to a question can be yes or no, or maybe don't know. But like yes is okay, is one, and no is zero. So that is just a representation of if something is true or false. So boolean can be true or false. Either you know something or you don't know something. You can't be in the middle, right? I know it or I don't know it. You can't be in the middle, right? So you kind of know things or you don't know things. So something can be true or it can be false. So which is boolean. If I click on this converts into a checkbox. This is true and this is false. So where is this thing is useful? If I say that, let's take an example right now. If I have an if then else patch, it's so we're talking about the data types, and don't worry about anything else which is right on the screen. Just worry about the type boolean. Okay, this boolean can be passed into this condition because this is a condition is a boolean type. What is a condition? Condition can be either true or can be false. So this condition is this patch is saying that if this condition is true, then this. If it's not true, then this. All right. So if I say that, hey, if this condition is true, then give me 5. If this condition is not true, then give me 3. All right. And now these are my number. This is my number. This is also my number. And whatever comes, yes, Srishti.
Sir,
Yes, Srishti, you have to speak again. You were not audible earlier. Srishti, you there?
yes, sir, I am there.
Yeah, you were saying something?
No, sir.
Okay, I thought you raised your hand. All right, no worries. So this if then else patch has a this is a number kind of if then else, but don't worry about it. We just want to understand this boolean at the moment. So this is the output and this is the input. There are three kinds of input to this thing, and there's only one output. Inputs to this patch can be numbers here, like this 5 or 3, because the number type. And output can also be a number because it's a number type. So if I say that this condition is true or false, I should get a value out of it. Okay. And now understand this. Right now it is false because it's not checked. So it is false. This patch is functioning and it is giving me 3 as output, right? Because the condition is not true. But if I say, hey, make it true, then it becomes 5. Is that understood to everybody? This is a very important concept because right now it's just an example, but then how you can use it this in Spark is that, like, let's say, hey, if you blink your eyes, then like if you blink in your eyes, then maybe rain, like maybe Halloween, or it's Happy Diwali, it's something like that. It's like if I open my mouth, like if mouth open is true, then do this. If mouth is closed, then do that. So that's how it is useful. So you have to like understand this. If you have any questions in this one, let me know, as I'll go to the next data type. All right. Next we have color. So you see now that this patch can't take this. This was a Boolean thing, right? So this can't take this color input. So we have to disconnect it. Else it's gonna throw us an error, and the error is that conversion, some sort of like data type conversion, because that's not true here. All right. The color value is by default, it's a kind of, I think there's no color into it. So by default, it's black. I guess sometimes it's transparent. So when you take a color input, it's kind of you can just click on it. There's a color picker opens up, and you can pick any color from here, and that color would be applied to this input. All right. And how we can use this is, first of all, you have to make it opacity 100%. By default, it's 100%, like it's my settings that make it transparent. So I'm just gonna enable this thing, and yeah. So what if I take this material, and initially I've applied this texture here. I remove this, but my texture can be a color value. So if I apply this a color, this color is going to be applied to the entire rectangle, right? So this is how the data types are useful. They're if you apply a different color, let's say, so some nice color, like maybe this one. Super slow at the moment. Yeah, so these are applied here. Okay, I think it's pretty simple. It has a input as a color and output as a color as well. Then we have a number. We just talked about a number. Interestingly, if you pass the number to the texture, like to the material of this, which takes a texture value, a color value, this is going to be treated as 0 or 1. So from 0 to 1, 0 is going to be completely black, I guess. No, 0 is going to be completely transparent, and 1 is going to be completely white. If I am in the middle, I'm kind of controlling its opacity, like the white color's opacity, right? And so basically we don't have to pass a number here, but so like if you do, then that's what happens. Then we have pulse. This is interesting. Okay, pulse is really interesting, and it's going to be super useful as well. Consider an example of a switch, a two-way switch, where you have a, no, not a two-way switch. What do you call that we have a doorbell, right? Like somebody comes and they press just once, and then as soon as somebody press the ring, the doorbell, there's something in the house starts playing. Somebody's home, open the door. Not like this. You probably have a different ringtone, bell tone, but so the pulse is responsible for that. Like, so what you did was they just pressed the button, and that button generated a pulse, and that pulse went to that bell, and then like, hey, start, and then it started, and it just went off. So for whatever time it's gonna be on, like let's say the pulse is on, and then for whatever duration the audio file is, it's gonna play and it's gonna stop. So it is different from the Boolean. Okay, how it is different from the Boolean? Let's take a value. Now, if I screen tap, there's a patch called screen tap, which generates a pulse if I screen tap. So if I click on my screen, this is going to generate a pulse. Do you see the dot? Like as soon as I click on the screen, there's a pulse generated. Yeah. But this Boolean is different. So I can't pass this to here, right? I can't do that directly. I would have to have a switch in the middle. So to convert a pulse to a Boolean, I would have to have a switch in the middle. So if I had the ring bell, and if I want that, if I press it at the 8 a.m. in the morning, it should be running all the day. If I want to do that, I would have to do something which keeps repeating it. Like as soon as it ends, the pulse should do it again. So I would have to create a switch in the middle and say that, hey, if I do the screen tap, then you turn on the switch, which is on forever. So if I do that, so that pulse ended. It's like a very short life. It started and same day it's dead. But this is forever. It's not going to change. I could do this a flip as well, that if my dad comes, then turn on the switch. But if my mom comes, then turn off the switch. So it's like that, like, hey, turn off, turn on. Let's take an example, a good one. Okay, so let's say now we talked about the Boolean, the pulse, and the color. I think they are enough to get us somewhere. So I'm gonna take an animation patch. This animation patch is going to play. It has some sort of inputs and some sort of outputs here. Okay, so the inputs are like, hey, play the animation, reverse the animation, reset the animation. Like if something is moving ahead and if I pass reset, should go back to the original position. Stop the animation somewhere, and the duration, like how much time should the animation should run. Going to quickly add a plane in the scene, and this plane is going to have a material which is flat. Very quickly you can add these things, and I'm going to give it a color which is nicer than this. Maybe this color. Oh, the color is nice and cool. Okay, so this color, I've taken this plane. I'm gonna just move it a little bit upwards so that it doesn't cover my face. What I want to do is that I want to kind of change. Okay, before we change that, let's talk about one more thing. There's one more type of input, which is number. We've talked about. Text is nothing but just text, like, hey, hello. You can just type it here, and then this would be the output. Like it takes input as a text, takes output as a text. And then next we have is vector2. Okay, so vector2 is a data type which holds two values together. So like those can be two numbers, those can be, yeah, two numbers only, nothing else. There's nothing else is supported. Like they can't be two text. There has to be like two vector, then we're talking about a number. So consider an example, like this was 5, but let's say I want to have 5 and 10. So two values at once. So then there are vector 2. So like 5 or 10. So why these are useful? These are useful in a place where I say that, hey, what is the width of my rectangle and what is the height of my rectangle, right? So two attributes. So we can pass them together, like, hey, my phone is, we were talking about the phone, right? We were talking about the screen size, right? So my phone's screen size is 375 width and 667 height. So that is where it is useful, so that we can kind of, we don't need two values to manipulate them. We can use just one vector to value and manipulate them. Similarly, we have three vectors. What if something has three attributes, like a cube, like it has height, it has width, and there's length. So three values. It has colors like red, green, blue, like three colors. So they're like multiple attributes for the type of objects which has three attributes. So we have vector 3. Then we have vector 4 as well. Vector 4 is usually we are going to use it um, in in color values. So every color is made of four parameters: red, green, blue. So we can make any color out of these three colors. Like all the colors in the world are made of RGB, these values, like different color value of this. Like if you mix red with green, you will get some sort of orange or like that. So there are like different combination of these three colors, and then every color is made out of them. The fourth attribute is the opacity, like the alpha. We call it alpha. Alpha could be 0 and 1. We talked about in the last session is what that. Um, so it could be either 0, like do not print it, or 1, like print it fully, like no transparency. So like the fourth attribute is the transparency. Um, we will explain this in some time. So vector 3 is important for this animation. So what I'm gonna do is that I'm gonna play this animation when I screen tap. So if I screen tap, play this animation, and this is the progress, and this is like when this is completed, like what this is going to do is that when I screen tap, this pulse is going to pass a pulse to this thing. It's going to play for 2 seconds, and the progress would be 0 to 1 always. Like the progress would be 0 to 1 always. Like um so initially we are at 0, but then we're going to start and we're going to finish the animation at 1. Now how much time we're going to take in this is our duration, but our progress will always be from 0 to 1. So we are at play right now. We clicked it. It's going to play the animation and then finish it. When it finishes, this pulse is passed as well. So this progress, I'm going to add a transition to this. Okay, so this transition is a vector 3, and this transition is that I want to make this plane like stretch a bit, like maybe increase its size. So how do I do that? I will take out the scale. All right, I'll take out the scale, and right now the scale is 111. So what I want to do is that I want to stretch it in the x direction, or maybe stretch in the y direction. So I don't want to do anything in the x direction. I want to stretch in the y direction. So initially I was at 1, then I want to go, like I want to start here, right? I want to go to make it 3. Z direction, just keep it 1, no changes into this. Uh, Scale, if I make it 0, it's gonna compress. So I'm gonna just make it 1. So if you see, there's no changes anywhere else. There's only one change in the y direction from 1 to 3. Initially we were at 1 1 1, and now we are at 1 3 1. And I'm gonna pass this to this guy. All right. So if I click on the screen now, if I do the screen tap, if I do the screen tap right now, we're just focusing on the upper patch. If I do the screen tap now, it's going to increase the from 0 to 1. Correct? Is that clear? All right. Do you have a doubt, Divya?
Yeah, can we add animation in any object like rectangle or something like?
Yeah. So see, animation that we have added here is it was not related to the object. It was related to the parameter, right? It was related to the vector 3 attribute, like what is the data type that you are processing here, and then what is it that you're passing it to. So I'm passing it to a 3 scalar value. So let's say I want to pass it to a 2 point value. So like if I would have to like make changes accordingly, right? So right now I'm passing the attributes. The animation is applied to the attribute of the plane, not the plane. So the plane, so yeah, you're indirectly you're passing the animation to the plane. But if you like talk a narrow, then we are kind of passing animation to the attribute of the plane. There are multiple attributes there. We could pass the rotation also, we could pass the position also, but we're doing that to the scale.
Yeah.
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 All right. So this is the pulse is clear, right? The next thing is that I wanted to kind of differentiate between pulse and a boolean, because this is, I have noticed like most of the creators have this doubt, and most of the creators they're like kind of in between a pulse and a boolean, and they're not able to kind of get it through. But if you understand the concept at the base, then you're never gonna like stop at any place, like, because the concept should be always be clear. um, what if I have a loop animation? Like, so just like animation, we have a loop animation. As the name suggests, it is going to loop the animation after every 1 second. It is going to loop the animation after every 2 seconds. If I put it to here, but to enable this, uh, just compare. Here we had play, here we had enable. So to enable this, I need a boolean. Here I needed a pulse. Do I have a correct understanding? Yeah. So what do I do is that I can't pass this pulse here. If I do, there would be an error, or there would be a different patch added to it. Spark does that automatically. If you pass a pulse to a boolean, it is going to add a switch by default. Go ahead, Divya.
Sorry.
You have a question?
No, 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 not right now.
All right.
Okay. Sorry, my hand is up here.
Okay, it's okay. So I am going to pass this boolean which I created. Like if I screen tap, then make this forever, like this boolean to forever. So if I do that, first of all I have to refresh my page, because last time I turned it on, it's on, right? So if I now the progress is attribute is same. Now if you see that, like, these guys are all same, like this is not going to change, because the transition, we want to transition, we want to make this smaller, bigger. The only thing that we are changing is that we want to do it again and again and again and again. So we're doing the same thing, but just again and again. So we don't want to change anything here. We just want to change the way we are doing animation. So here we were doing animation. Here we want to do loop animation, and the progress is connected to this time here. So if we say goodbye to our one-time animation to forever animation. And now if I screen tap, this is just going to go forever. Like, I don't have to do anything. It's just gonna keep doing it. It's just like it's it's not gonna stop until eternity if you close the project or if you do something. So if I screen tap again, it's gonna flip. It's gonna stop the animation right where I put screen tap. If I do that again, it's gonna start right where if I pause it. Like the so it stopped at 1.683. Uh, this time stopped at 1.67, 2.467. So whenever you stop, that's gonna do. So it's an interesting concept in making a lot of games. Like, let's say if I blink my eye, then You know, like you must have played a lot of games, like if you blink your eye, then fire something, or stop something, like something is passing by. If you blink your eye, then stop. So this is how it's done. This is how it's done. Like you kind of enable or disable the animation based on that. Now, interestingly, if I use the turn on switch here, so flip was on. That's why it was like flipping it every time we were tapping the screen. But if I turn it on, if I put it to turn it on, it's going to be turned on forever. No matter I screen tap or not, it's just not going to stop, because the screen tap is going to enable this. Now there's nothing else. Like, what are you passing? You're passing turn on again and again and again and again. It's not going to change. So this was animation, loop animation, uh, vector 2, vector 3. Now we're going to talk about vector 4. So let's talk about vector 4. I'm going to delete everything here. Disable this guy. Enable this guy. Okay. There are some things about the camera, like okay, whatever we see in the scene, okay, Spark AR is like augmented reality. So whatever we see or do or make in augmented reality is kind of augmenting the reality. Like, so whatever we see in reality, we're augmenting it in AR, in digital world. So why do we see things? We see things because we have eyes. But is that enough? If we don't have light, we won't be able to see anything, right? So we need a light system. So we have light system here. There's a light system. This is the light that you can see. This is direction light. We call it like a sun of the AR. So this is similar to having a sun directing at objects. There's an ambient light. It's a constant light which is passed to the entire scene. If we don't have these lights, and so right now we have a flat material, like we don't have a material. So if you have a standard material and then this, you don't pass the light at all, there would be a dark scene. So to come back to the point, we see things because there's a light in the space, and that light is kind of reflected back to our eyes. So if a camera is seeing something, then the light is being reflected on the camera from the object. So we need a light system, like that's what we have augmented in the AR. So the camera has these attributes, like the camera texture extraction. So whatever we are looking at is the camera texture. The texture is that's what being seen by the camera. So if we extract it, it's going to be under the camera texture. We actually talked about it last time, but it's just for the people who were not there last time. So this is the camera texture, and we also have some other functionalities here, which is segmentation. Segmentation is kind of, so entire camera texture is into the camera texture. But what if I want to segment users out of it? Like if you see a person, then give me that person out like separately. I don't want to like see anything else. I just want to see the person. I just want to see humans, I don't want to see a cat or dog. I just want to look at humans. So that is why we have personal segmentation. This is person segmentation. We also have hair segmentation and skin segmentation, where so this works similarly, like it's just like alpha. So earlier we were passing segmentation into alpha. We will pass hair segmentation to the alpha. So we will see only hair. If we do that to the skin, whatever we do is applied to the skin. So that's there, which is a simpler task that you can try on yourself, because you've tried personal segmentation. Now you can try on um, the other two kind of segmentation. This concept is same. Just import them into this Spark and then try to use that alpha to whatever texture that you're trying to make. Coming back to the point, we want to use the camera texture, and I want to bring it to the scene. Enable this guy. So right now, my canvas, this rectangle has a material which is nothing but just a no texture is there. There's no texture, right? There's nothing is applied here. So what I want to do is that the white color is applied. If I change this color, it's going to be applied there. But I don't want to change the color. I just want to tell you these attributes. You can change the colors. So this texture is also a bring out here. And if I connect these, this is going to be a, like the entire camera is being projected onto my material. I'm going to call this guy like camera eye, like whatever the camera's eye is looking at, we are able to see. And this material is also matte. Accidentally deleted that. And I just figured I could have just done Control Z, but that's okay. Yeah, I just want to rename this guy to Matt. It is always a good practice to rename your things to something that makes sense to you, because when you kind of work on larger projects, you won't believe, like you start working on something and then by the end of an hour or 2 hours, if you continuously working, it just becomes so large. It's become so much to see, like where's what. So it's better to kind of manage it with good names. So I'm gonna like camera eye. All right. And this camera texture is this camera eye. Now I see my camera, I see my texture is passed to this guy. So what do I do is that I want to explain you with a vector 4. Now you see that this is a RGBA, right? So this is a 4 vector thing, like red color, blue color, red color, green color, blue color. So the entire everything, every color that I see here is a mixture of red, green, blue, right? So we are taking all that information and passing it to our material. So that is why we are able to see the actual colors right here. So what if I kind of want to manipulate this thing? That don't go entirely. Let me change you a bit and then project you on the material. So how do I do that? I can unpack it. There's a patch called unpack. Okay, so there are many patches here. Okay, and it is impossible to talk about everything, like every patch. What does it this do? What does that do? But we're gonna take examples and kind of import them one by one. We'll be able to see what patch does what. So if you like click on the unpack patch, you will see that unpack a number or a vector 2, 3, 4 into separate values. So if I have a RGBA, I can make RGBA separately, right? So that is why I'm going to unpack this guy. It takes an input. It takes input like whatever we set here. If I set vector 4, it is going to take a vector 4 input and give you 4 different single number inputs. Okay. So 4 is converted, like 4 factor is converted into 4 single vector. Okay. Very interesting concept this. Okay. Now, what if I just pass the X value to this guy? Do you see the difference? This means that I am not passing green, blue, or alpha per se. I'm just saying that whatever my red color channel had, just pass that. So wherever it sees the red color, I'll tell you. It's going to react to the red color only. I can't see any blue color or a green color in the scene. This is only red color, right? But if I do that to R and then we had G, right? Green. So we're only gonna see the green colors. So whatever a combination of green colors, like wherever I have green colors, it's just gonna pop up. So for example, This is green, so this is like clearly seen, right? And other colors are a little bit lower tone. So goes with the blue, and that is alpha, which is like completely white. So so make it white. Okay. Now this is how it was. I unpacked it. I can pack it back. Okay, so if there's a pack, there's also a, if there's unpack, there's also pack, right? So these functions are funny as well. Um, so vector 4, if I do this, like unpack and pack it again, and then just do this, it doesn't make sense. Like, it's similar to, this guy. Like if I do this and if I do this, it's the same thing. It's like I have unpacked it, I packed it, I made the same thing. But if I apply some operations here, like multiply my x value to something. Okay, right now it's just one, so it's the same thing. But if I increase it, so what am I doing here? I'm kind of increasing the red component, because the first is what? R. Second is what? Green. So I'm increasing the red component in the scene. So if I do that, it is going to increase this. So if I directly connect it, it's the original texture. But if I connect this, now they are different. What if I want to connect it to 1.5? It's a little bit reddish. Then I want to maybe add a green, like maybe add this time, not multiply, and add like a 0.3 value, and I pass it back to this. So just keep seeing what is happening here. We are kind of passing those values to manipulate them, manipulate the colors of the screen. Like now this is applied to everything it sees in the. So this is how the most of the color filters are made, like how they change the colors, how they inverse the colors. And this is alpha. Okay, this is going to control the opacity basically. So if I add let's say if I add something, it's gonna make things brighter, like maybe just like throw some more light onto it. If I subtract it, like if I just do the negative values here, yeah, if I do the negative values here, so whatever was applied above is going to have less intensity over the entire scene. Yep. Any questions into this? Is this clear to everybody? Because I have a lot of questions when I kind of understood this concept for the first time. What if we could do many functions here? Now, let's kind of apply something that we have recently learned. We learned loop animation. And we learned that this value goes from 0 to 1. So what if I multiply this to 0 to 1? This is going to change my colors continuously, right? And if what if I kind of also, now that is like 0 to 1, but I want to go beyond. I want to use a number which goes from from -1 to 3. And that is go here, this go here. This just can go like super crazy as well. You can experiment with the values, what works best for you, and then like like yeah, there's a party going on here right now. So this is a type of animation. Like which type of animation? The curve, like I told you about the curve, the kind of curve which is goes from 0 to 1, like from 0 to 1. So within the time frame of let's say 5 seconds, this progress value goes from 0 to 1. Takes 5 seconds, it goes slowly, slowly, slowly. So what if this happens when it goes like linearly? So what if I want to go it faster at the start, slower in the middle, and faster at the end? So there are like a different kind of like overshoot, exponential, circular route. Like circular route is like when you come in, like you come at a speed, but then slow down and then just go out. So it's just that curve is making that progress. Right? So this is how you can like control if something is jumping, it feels like jumping. If it's a linear, it's never jumping. But when you jump, is that you go faster at the start, then you slow down, then you start slow down, coming down, and then you come fast. So this is like a curve, like a going up and down. So like a sinusoidal curve. Okay. So if I go as like a sinusoidal curve, and this is going to be a different way of transitioning. If I mirror this, then it's gonna go and come back. Right now it's going, starting again, but now it's mirroring, so it's gonna go, come back, go, come back. All right. I hope you understood this unpacking of camera texture, because this is usually kind of, this concept is a little bit advanced as well, but I hope I've taken very simpler examples to explain this. So you could do some color filters using this, you could kind of manipulate some things. All right, let me see, goodness, next. Cool. You have any idea how to export the filter, how to test it on your devices? That if you connect your phone using a USB cable, you can, like, whatever you're doing here, you can send it to now you have to select an experience, like what are you making, whom you're making. So we're making for Instagram and Facebook, and you say done, and then you can kind of send it to Instagram directly. You can also send it to your phone. If I'm going to connect it to USB, you can connect it and send it to my phone as well. So as soon as my phone is connected, it says like send. And if I send it, there is an application called Spark AR Player, which is not open right now. So you have to open it first on your phone, and then you have to do it again. So now whatever we were doing here is transformed and is sent it to my phone now. So my phone sees a green screen now. We could send it to Instagram. There's a quick trick. You can send it to Instagram and also send it to your friends at the same time without even uploading it. So let me give you that. Yeah, so what it does is that it uploads on the server. So you can quickly test it or quickly send it to some people. Maybe right now I'm gonna just send it to, like, so this is going to send it to my Instagram app, and I'm going to like test it in my Instagram app directly. Most of the time you want to test your filter into Instagram apps rather than testing it somewhere else. When I do that, I see a test link here, which can be sent to maximum 50 users. So if I copy this and if I send it to you guys, you can kind of click on it and open it in your phone, and this will open on Instagram. So this is like as simple as that. Like that's how you can test it. How you can upload the filter on Instagram is that you can publish it, export the file. This is going to give you an .ar export file. But I think these are like similar things that you can do like very fast. But I hope you're well aware of that. If you're not, let me know if I can explain that as well. You guys familiar with how to publish your effect on Instagram? You can turn on your mic and say like, yeah. Yeah, Divya.
Yeah, I saw that your profile and had a shot on iPhone.
Yeah.
Yeah, that was made by this Flip and Julian based on that.
Sorry,
Based on that.
which filter are you talking about? Short on iPhone.
Yeah.
Yeah.
Uh, on which basis you have made there? Like Julian and Flip and that back and all these things.
Yeah, yeah, everything that is combined of these all of these things, because of course I'm switching among options.
Yeah,
So
yeah,
that is why how am I doing this, that I have a I have a null object which is then divided into some parts, and those parts are assigned to planes, different planes divided into kind of like you take a ratio of 100%, and then let's say like this portion is going to indicate 10%, then 20%, and then you slide it off. And every slide, when I say that way, if you are at like 10%, then enable this guy. If you're at 20%, then enable this guy. So 10% and 20% is just values like 0.1, 0.2, 0.3. So that's a representation. But yeah, you're correct. You could make this using flip. You can using all of these concepts like switching among options, right?
okay.
This green color looks so weird. I'm gonna like disable this guy.
Yeah.
That's even worse. This is the pink. I'm gonna make it -1. Okay.
And how to enable that neon lights behind the person?
Neon lights.
Neon lights. Like
Sorry,
you
what?
posted that video on Instagram. That person behind the neon light.
Person behind the neon lights. Which one are you
I mean,
talking about?
wait.
Neon lights behind the person?
Yeah, yeah, yeah.
Yeah, the dance filter you mentioning.
Yes, yes, yes.
Hmm. So that one is well, there are a lot of advanced concept there, but it's not that advanced. I think we are able to cover that in some time, maybe like next session. I could have gone a little bit ahead, but I hope this doesn't happen like in every session, that if we are not like able to do our assignments, if we're not able to um, like if just one student does all the assignments, how am I like going to take the entire class further? But like I would really need your support, like so that like we can do this thing together. But I'm really happy, even if I'm able to teach 3 or 4 students out of the entire batch, I will feel that I'm successful in doing that. But I would really hope that next time you come with a lot of questions, because I would love to answer them. Today I feel like a little bit obscure. Like, should I tell this concept or not? Because I don't know if you understand or not. But like I am sure like Divya understand everything, because he has done his assignment. He has been in touch entire week. He's been asking questions, and there was a day when Divya was arranging sessions and talking about things to other people. And I was like so happy that day, Divya. That was a really great initiative by you. So if you keep doing that, we could talk about all those things. Coming back to your question, that uses render passes. It also uses a little bit of like that frame is delayed. So it keeps pushing those lines one after other, and
Yes.
also follows the movement. So that has a delay frame into it, that the kind of we feed the frame again back to it, like whatever happens, delay it and come back to it, and again and again and again and again. So we kind of do that in a loop using a delay frame. It's an interesting concept that we're going to learn soon, but right now, if I talk about it, it won't make any sense to you. So before we go that, I want to talk about render passes, and then we'll go to delay frame. So we can wait for that. But glad to know you're curious about it. This is an interesting concept.
Yeah.
I would not recommend like to you to go to the YouTube videos, but there are a lot of tutorial on Spark Air website as well about render passes, if you want to go and like see like what means what. But I'm sure we're gonna take that in like at the next session. It's planned in next one, so we can talk about it there. But it uses personal segmentation, so you know that concept already. It uses animation, you know that concept already. The only thing that you don't know right now is render passes. So next time you will be clear with that as well. How did I create neon colors? That is SDF. That also we're going to cover, I think, in next session. So you can also create SDF like outside Spark also, if you know some like other tools like Photoshop or Blender for 3D tools. So you can create those neon lights outside as well. All right. Any other question you have until so far in this session, or anything which is coming to your mind before I go ahead? Nope. All right. I want to talk about a very interesting concept, which is UVs. UVs. UVs are basically UV. I'm gonna write it. It sounds different than it actually is. So because coordinates, basically these are coordinates, where every screen's coordinate, every, so this entire screen space is made up of vertexes. Like there are different vertexes. Every vertex has information. So these UVs are responsible to kind of printing it. So conceptually, I'm going to disable this guy so that you can see my face. Yeah. How this camera texture is visible here, like what is going on behind it, like what kind of mechanic, everything in sort of 3D onto our screen. Anybody has any clue, like how are we able to kind of make this difference? Like, so right now, if you see that, these glasses are ahead of me, and there's this gap here. If I put my pen here, you see that there's a gap between these two. Like you understand everything, right? Everything is happening in 3D. So how this, yeah, so this is 3D, right? X, Y, Z values are 3D, but this screen is not 3D. This screen space is either X or Y. Whatever we are screen coordinates we're talking about is that, hey, 375, hey, 375, 667. We are not saying like, hey, Z direction, maybe we have this values. We're not, right? So it's very interesting that we have UV values. These UV are coordinates, basically just coordinates. So if I talk about a particular pixel on the screen like this one, so it will have a coordinate like, hey, this is 0, 0. This corner is 0, 0. And this point is the center of the screen. So which is like whatever I have in the X direction, like this direction divided by 2, and this direction divided by 2 is my center, right? So these are the coordinates. Okay, so we are talking about these UV, and when I say UVs, basically I say UVs, like coordinates. Okay, so now you would understand. This is how we pronounce it. You can also say UVs, but not professionally, just like in a fun way. But it's like they're UVs. Okay. Now, so how is it happening like this? What are the UVs? To answer that is that it's a 2D representation of a 3D coordinate system. Okay, so whatever is happening, whatever a camera sees in the 3D space, the UVs are responsible to translate that into a coordinate system, which is a 2D coordinate system. So uh, these UVs are so these UVs are coordinates of the vertexes. So there are like vertexes on the screen, and then UVs are the coordinates of those vertexes. What is a vertex? A vertex is a combination of a position. Like what is the position of the vertex? what is the normal? Normal is a perpendicular drawn from the point. So this is a point. If I draw perpendicular to it, there would be 3D. So this is like a perpendicular, like if a 2D point is there, and if I draw perpendicular to it, this would be in the Z direction. So normals are generally used to give depth to things. And there are texture coordinates. So vertex is made of 3 combinations. We are going to talk about vertex coordinates, which are UVs, texture coordinates, okay, which is in the 2D space. There's a patch which is called like there's a patch here which is called vertex attribute. So we talked about 3 vertex attributes just now: vertex position, vertex coordinates, and there's a vertex normal. Okay, so in this vertex attribute there are some type of attributes here, which are not all of them are useful. Well, they are useful, like if you want to use them, but you have to kind of go into like shared knowledge to understand everything. But to talk about it, I can just like brief you a little bit so that you can have a direction to go. A local position is just a object's local position. It's a, I think that's a 4-dimensional vector. Local normal is a 3-dimensional vector like XYZ, and this is a perpendicular to the object space. Local tangent is again four direction attribute like X, Y, Z, and something like W, where X, Y, Z are just like the coordinates where the tangent is like. So consider this is a vertex and this is a tangent to it. Now one point can have 2 kind of tangent like this or like this, right? As this is math, right? So the last attribute like the Z, the W, decides the direction, like, hey, it is a negative tangent or is it a positive tangent, like that. So this is a local tangent. Texture coordinates are the coordinates of the thing, like it's a 2 comma 2, 200 comma 200, 300 comma 300, 100 comma 400, whatever texture coordinates. Vertex color is what kind of color information that particular vertex has. Like right now my glasses has a like a transparent color value, like some whitish color. My hair has a black color value. So whatever coordinates my hair are lying right now on the screen, they're assigned a black value. If I move, the color and the coordinates move with it, so that is why they stay black, right? Then we have local base position. This is again a vector 4 value, I think. Yeah. And this is a base that we, okay, I think who left this? Okay. All right. So we're going to talk about texture coordinates. So right now, my screen is made up of texture, like vertexes, which has texture information at the texture coordinates. So my texture is here, my texture coordinates are here. So they are sampling together to give me this material. Right now they're not connected, they're not even visible as well, but this by default we see this here. But if I make it visible, you see widescreen because this is not passed yet. So I have to sample this into a texture sampler, which is, so the first time you see UV here is, I think, or the only time you will see UV here is in this patch. So texture is going to pass from here, and I'm going to say like my UVs are my texture coordinates. So I took all the coordinates out and passed them as UVs and said to my camera eye, like, hey, pass that there. So now everything, does this make sense? Like until so far, what I did is took my texture information, applied to the texture coordinates. So this everything is right where it should be right now. But what if I want to manipulate it? What if I don't want it? I don't like the way it is. I want my face to be I'm an alien. I don't like my face like this. I want my face like wide, like my face like long. I don't like this. So this is what augmented reality is. You can change anything to whatever you like. So I take out, so coordinate, texture coordinates is a two vector thing, right? Because X and Y, right? So I'm gonna unpack it. Unpack, pay attention here, ask wherever you have doubt, because this is something interesting and you're not gonna find this anywhere else for sure. I'm pretty sure. So pay attention, and if you don't understand this, let me know. This is a vector two thing, all right? So what I did is that I'm gonna like just take it elsewhere so I have enough space. What I did is that I take out the texture coordinates, which is a two vector thing. Then I have X and Y now. By default, it shows zero because yeah, because for these patches it always shows like that, because it's like I have a shaders and which they are kind of converted into patch values, so they never show up a value. And then I'm gonna pack it back, just like I did this in the previous one, right? In the camera texture and while unpacking and then passing it to that. And then I'm gonna pass it here. Nothing changes, right? Because I haven't actually changed anything. It's the same thing. But what if I manipulate the X? I kind of add something to it. All right. Right now I've added zero, but if I add something else, so what am I doing? I'm shifting my coordinate system to bit of into X direction. So whatever is, like I've been shifting this, like, now I'm not there in the camera anymore. You see my point? Like, so I'm moving. I'm not moving, but my camera is making me move. Yeah. So after a point, like after, I think if I go beyond one, this is going to just stretch because it doesn't have information there. Like if I keep moving my texture and my camera can't see beyond that, it is going to take the last pixel and stretch it forever. So I think this starts happening if I go beyond one. So it's like this is one, and if I do this 1.1, if you see that this is stretching, these points are stretching that way. And had I done this, so I just want to do this from like, let's say 0.1. Yeah, so this is a bit shifted towards this side. What if I want to multiply my y coordinate to 2? So what I did is that so my entire scene is kind of compressed into lesser area. So I don't have enough to put it in the screen. So my last pixel is being stretched. This, if you see, if my last pixel is my finger, then it is going to be stretched. If it is this pen, then it is going to be stretched at the last point. You understand this? Because it doesn't have the information. So if I'm just going to do 1, and just to give you a perspective, if I do 1.1, let's add things, then multiplying. If I add 0.1, so why is it replicating after this and that? Because my camera's y coordinate is this only. It is not seeing beyond it. And why it was not doing for the X direction is because the camera was seeing much more, but my screen was smaller. My screen was like this. So it was not printing everything. It was just printing what was there based on the screen resolution, based on this texture coordinates I had, based on the texture was projected from the camera. So I had some room to kind of play around with my, what my camera actually sees. And this is also camera of my, yeah.
Sorry to interrupt, but can you show that again, that y coordinate one?
Sure. So What do you want to see? You want to see addition? You want to see multiplication?
Yeah, both.
All right. So if I change this value, this is basically what I want to do is that I'm moving my y coordinate up, right? So my whatever right now I see is going to be shifted a bit upside. All right. So whatever is there in the down, it would come up, right? But there's nothing down. There's nothing there. So there's no this. The camera only sees this. The camera doesn't see beyond this. So that is why it's just going to stretch this thing, the last pixel, whatever the last pixel is, it is going to stretch it. Yep, Divya, understood?
Yeah, yeah.
Uh, Interestingly, let's do one more thing with this. Instead of multiplying, let's multiply this guy. Yeah, so you have, now you see that we have these patches like multiply, or so this x was 0, so that is why it was not taking anything. I'm going to delete these things. So what we have right now is nothing, just the simple thing. There's no changes for now. If I multiply it by 1.1, this is again going to compress it. Yeah. So right now what I'm doing is I'm kind of multiplying it by 0.7, which is kind of dividing it by like a smaller value than 1. Like, so basically if I multiply this from more than 1, it is going to compress the texture, like it's going to like compress it in a way. Earlier we were adding things, so it was like I was shifting, but right now we are kind of multiplying the texture. So basically we are compressing the pixels to be more intense. Like, so if you were holding one value earlier, 1 pixel, now you have to hold like 2 times of it. So basically everything that was there, it would condense, right? But again, it will condense up to a point. After a point, I won't have those, and you will realize that this will only condense until the screen scale, which is 2, right? If I go beyond 2, it is going to replicate, right? And take this example, okay? I'm just going to change it to some other phone. Let's change it to iOS device, iPhone X. And iPhone X has a different system for the screen scale is 3 here. All right. So if I go here and if I go like 2.1, 2.3, 2.4, 2.5, 2.6, 2.7, this is still printing, but then I go near 3 and then starts replicating the texture. So I think it starts a little earlier as well. All right, I think some inset problem, but that's a concept is like, if you go beyond that, it's going to start replicating the values. All right, so, but if you go less than 1, it's going to expand it. Like, so basically kind of like dividing it by 2. Dividing it by 2 is kind of maximize everything. So now since my whatever I had is magnified, I have some values in y which are not seen. So if I kind of go again and add some things in y, I can kind of traverse. I can kind of shift it without, see, oh yeah, it's not going to print like because that's, let's try some higher values. Oh, just because it is we're doing in the x direction, we're not doing in the y direction. So if I do that in the y direction, so if I divide this by 2, yeah, so now my it's divided a lot, 1.5, let's say. So I have some textures below here. So then if I want to add it to this, then I can kind of traverse through it. Mm, no, I think we can. Oh, okay, got it. We have to add this here and this here. Now we can add. Yep, makes sense. But that's enough. The concept is to kind of see this into perspective. But what if I put some sort of animation? There's a patch called sign, which takes any value to and convert it to like a sign value. Sign is from always -1 to 1. So if I do that, if I apply a sign here, and let's say a runtime patch is basically a time value from start from 0 when you restart the filter, and then it just keeps going on. And if I do that, this is always going to give me a value from -1 to 1. So this is going to always change between -1 to 1. You see that these values are always from -1 to 1. And if I pass them into X direction also, that's going to keep changing as well. So yeah, right now there are like some other things, but you can see that we can kind of compress everything into 1 pixel, and then uh, also go pixel by pixel for changing those values. Interesting thing to note is that we talked about some pixel values earlier, and also did I mess up? Yeah, I think I forgot the chain of thoughts. I think I told you the something in the last session, which was now explained better. Yeah, remembered. I told you about the tiling, right? In the last previous one, the tiling was the how the tiles were working. Like you divide a texture into 3 x 3, like 4 x 4. That was on repeat. But if that's not on repeat, it's gonna make a tile, and then other things going to be put into the last pixel of it because there's no texture value. So that's the similar concept of kind of this UVs dividing into 1 pixel and then other. Basically, we tile it by pixel. So if I just go so higher, like multiply it by so higher value that it is condensed into just 1 pixel. So this entire thing is going to be pixel into 1. I hope that makes sense. I hope this is understood in a better way. Any doubts so far? Anybody other than Divya? Doubts? This is good that you're understanding everything. I'm super happy. Divya, any doubts?
Not now.
All right. Yeah, experiment with this. Okay, I think this is, I think, too much to understand, especially texture coordinates and these values. I think you probably must have heard about these for the first time. I think I made my 10 to 15 filters and I had no idea about about these things. Um, but then I realized that these basic concepts were really useful to manipulate my UVs, manipulate my screen, to know about these things. And yeah, so now I'm going to come back to our this divide resolution thing, because this is what we wanted to discuss initially. And now we've discussed everything about the screens. So you understand the resolution, you understand the vectors, you understand how to divide. So I'm just going to take an example of a rectangle. This rectangle has width and height. All right. So we can do it in 2 ways. First is like we can have the width and height and then change it the way we're changing. Second is that we can kind of work with the texture that we're passing. So let's say this camera eye has the texture, this guy, where are you? to call you here. And yeah, so this is the texture that we have at our screen. But when I kind of change my screen, it just goes to next is gonna work fine. It is going to work fine. Because this is like a I think 1024 cross 1024 texture. Yeah, so that is why it fits fine. So it is also recommended that always have 1024 cross 1024 texture in Spark, unless there's some size problems, because that is like the maximum resolution you should go to, and always try to have a square or try to have a texture dimension which is a multiple of 2 to the power something. So like 64 by 64 is too less, but like at least 256 by 256, 512 by 512. So these are like a recommended dimensions. So what happens is that there are like a lot of things that happen, like filtering. So these are only applied, these UV tiltings are only applied when you have texture in 2 to the power something. If you don't have, if you have a texture like 1000 cross 1024, then you can't do that repeat or mirror or clamp. Like these tiling modes would never be done. These, oh, by the way, U tiling mode and V tiling mode is from the U and V, from the UVs, right? U is X direction, V is Y direction. So this is the second place that you're going to see UV in this entire Spark AR. Okay, so the concept is to kind of use a 2D transform pack. I'm kind of confused, like, how do I tell you about this? There are two problems that you face. Okay, one is the texture stretches out, and the second problem is that the rectangle is not enough. Like every time it changes the size, the texture remains there, doesn't stretch with it. So we use the width and height. Okay, we bring them out in the patcher. This is, so the computer is super slow at the moment. All right. So what we do is, what's wrong with this? Just a moment. Cool. All right. So what we do is that we take out the width and we take out the height. Okay. So right now it is set to 375, 67, and we divide it by a screen scale, and we see that this is the same height that we get from this guy. So we unpack it, and we unpack it to vector 2, and this is my X and this is my Y. So now every time I try to resize it, let's say if I want to resize it to, sorry about my laptop, it's super heated and super slow at the moment, but I hope the feed is coming through. All right, so if I resize this guy, you see that the width is changing, the height is changing. So is my rectangle's width and height. So it is never going to create a problem to me for any kind of device that I use, because the width and height are always passed according to the screen size or whatever you're using. If it's an iPhone, if it's an iPad, if it's small, even like a very small device. So it's Divya, is that understood? Like you had this doubt, right? With the um, okay.
Yeah, but when we stretch our assets is manipulate, like that doesn't make sense, which we put in.
Sorry.
लाइक हमने जो अभी ये लगाया है हेलोवीन लाइक मटेरियल में
Uh,
अप्लाई किया है हेलोवीन, तो अगर हमको स्ट्रेच करेंगे लाइक अपने अब जो किया हुआ है, सो दैट डजंट मेक सेंस, लाइक वो कुछ समझ नहीं आएगा कि क्या है एसेट्स में। लाइक
uh,
अगर हमने मेरा जो था उसमें मैंने आगे फ्रेम लगाई थी, अगर वो पूरी स्ट्रेच हो जाएगी तो उसमें जो लिखा हुआ है वो कैसे पढ़ाई देगा?
so there is no way there's a phone like this.
Yeah,
The phones are always iPhone 8, iPhone 8 Plus, or like that.
yeah,
So so this is for the rectangles width and height.
yeah,
That you're saying is about the texture. Okay.
yes, yes,
So
yes.
for that, there's a different method. So I told you there are like two methods. This is the first thing that about the rectangles. This is going to change. And
Okay.
you can use this, but if you even don't use this, I think Spark handles them by pinning them from these sides. But these are confusing, so I told you an easier way. What device, the resolution and everything. That is the simpler way.
Can we
That
use pinning? Yeah,
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 yeah, you could always use those. But I wanted you to understand the concept behind
yeah.
what is working with them and what's happening, because even if you don't understand and get confused with those, you can always apply these things. Okay, now let's understand that texture thing. Okay, um, we have a texture transform that you've already seen. We had a texture transform. Um, no, you have not seen texture transform. The texture trans we have seen texture sampler, which was taking texture in UV coordinates. Now we're going to talk about texture transform. We have 5 minutes left, but I think we can cover it. A texture transform is it takes up a texture, then there's a transformation, and this is what we want to do. We want to transform it to according to the screen size and everything, right? So there's a 2D transform pack. Okay, there's a because what happens when a screen changes its rotation or a scale, like, so this everything is combined into this pack, and we apply this to this guy. Okay, and then we apply this to our texture. Right now there's nothing, no texture is passed, so we take this texture. Okay, I want to take some texture which is, let's say, not as perfect as this is very perfect texture, so you don't see problems already. I want to take a texture which creates problems so that we can fix it. Just don't mind, I'm just gonna make it a little bit clearer for you. Laptop is super slow right now, so can't really uh, all right, so maybe just use the Halloween one for now. So basically, the idea is to translate them based on our screen size and everything. So right now it is 1:1. Okay. So my scale, if I make it 2, it's going to be larger. If I make it 2, it's going to be like larger in y direction. And then like it's going to increase that way. So what I want to do is that I want to maintain this ratio, like, because my pixels are like that my x direction is, my x coordinates are lesser, my y coordinates are more. Okay, so they have a ratio, so whatever the value of my screen size, if I unpack it, and if I divide the first one with the bottom one, I will have the ratio, right? If I divide my x with the y, I would know that what is the ratio of my x to the y. Now this ratio is less than 0. Of course, this is like 0.05. So if my y is 1, my x is 0.5. Correct? That's what it means, right? We've divided it. Am I correct? Do we understand this?
Yes, yes.
Yeah. So my scale is going to be accordingly. So I'm going to like multiply. I'm going to pack this now in a vector 2, and if that is 1, then this is going to be 1, and this should be my scale. Yeah, that should be my scale. Let me just think it through. This is my x and y. If my pixel, so I have the coordinate now. This is not going to make sense, right? Yeah, I think it's the other way around. Yeah, I'm sorry, it's the other way around. Like, um, if my x is 1, then my y has to be 0.5 to kind of compensate the ratio, because this is x by y, this is not y by x. Okay, what I done is that x by y. If I do y by x, then what we did earlier was correct. Okay, if I do like divide y by x, then there would be like, hey, this is my this ratio and this is my 1. So that would make sense, but in a different ratio scale now, because this is y by x and this is x by y, and how we perceive things is with x by y in the coordinate system. Is that understood? Like, to just refine it, what we did was we took out the screen size, we divided by x to y to take out the ratio of every pixel, and then we scaled it accordingly. Now if we want to zoom it out or zoom it in, we just can multiply it by 2 or whatever you want to do that. So you don't have to do anything, you just have to kind of apply this scaling ratio here and then apply that to your camera texture. Is that understood, Devya?
Yeah, yeah.
Any doubts, anything, any hesitation around it?
No.
How about Purva, Shruti? How was your experience? I think this was your first session, but how is it like? Did you have any experiences prior to this about Spark AR, or how did you make sense of things today?
No, sir, this is our first session and this was very interesting. Yeah, but as it was our first session, so um, all the things are not that much clear. But yeah, when I'll practice it on, I'm sure that I'll get all these things.
That's good. That's good. I hope you'll save a recording link, and then so that you can go through things that you did not understand, and you can always reach out.
Uh,
Always, yeah. Tell me.
So can I get the previous session recording?
Yes, Askar, are you there in the call? I'll ask Askar to send you. Askar will send you to
Yes, I will share it.
yeah. So you will have those recordings, and then you can go through, and then maybe next time you should come back with a lot of questions, a lot of doubts, a lot of learnings. If you kind of find out something new, teach me as well. I'm there. Um,
Yeah,
because
sure, sir.
yeah, fast software.
Yeah, but the rest, this all the things that you thought are very interesting. So yeah, definitely I'll try this.
That's good. All right, I think we have covered a lot of things today. There are some things that we could talk about, like audio reactivity and stuff, but I think that's for the next session. And for the next session, um, yeah, for the next let's move that for the next session, because this has been 2 hours journey already, and you must sleep if I continue now. I'll sleep if I continue now. So
Yeah.
yeah.
And
Divya, any feedback, anything that you want to share about your experiences that you've in past week while you were making filters? Were you able to create them easily, or like what are the
yeah,
things?
if you want to make something interesting, then find some good assets, and I'll suggest that make your assets in Photoshop and AI. Those who are new, so आपको कुछ अच्छा बनाना है तो अपने assets खुद बनाओ तो अच्छा दिखेगा. कहीं से डायरेक्ट उठा के मत ले लो, तो कुछ क्रिएटिविटी आएगी.
Okay, that's good. That's good. Actually, that's nice. If you create your own assets, that gives you a different kind of confidence. And we're only three people here left, but I wanted to do an announcement. Is that after the end of the um, our like sessions, our everything, our program, we are going to announce one like best campus ambassador, like a award, like a reward. So there are some sort of goodies as well. There's some prizes for that as well, and there's going to be a certificate for that as well. So yeah, I mean, like, this is based on performance, and there are some factors which are counting on this, which is going to be attendance, your homework, your assignments, the way you're kind of interacting. There are a lot of things in that thing, and I also like gonna announce that in the group so that like everybody knows about it. But since you guys are here, and so yeah, to make sure that you get that award, like it's good to have any award. Like if somebody announces any award and I'm always like, I want that award, that's for me. That's for me. So yeah, keep up the good work. And the main reason to have these awards is like to encourage people to learn, and then if you try to get those awards, you definitely would learn better, and I would be happy with that. So yeah, I think we are not anybody from South India anymore. Like, everybody understands Hindi now. Like, Purva is from Haryana. Shruti is also from Haryana. Divya understand Hindi and all. So like,
Yeah.
if that's the case for the next session, maybe we could also go in Hindi if that's a like language problem with anybody, because I feel like the interactions goes a little bit on the lower side. Oscar, have you stopped the recording already?
No, not yet. Shall I?
Yeah. You can stop the recording.
Okay.
Maybe crop the last parts also.
Sure.
We're just having fun announcing things.
Yeah.
Yeah, if nothing else, we can move ahead with the weeks, and